Session on your data structures, everyone. So, good afternoon, first of all. So, in yesterday's session, we discussed about something related to the introduction to data structures, where we have seen something related to your definition. So, what do you exactly mean by data structures? And we also seen the significance of data structures here, like what is the necessity of having these particular data structures? Why we require these data structures in all the programming languages? And we have understood that we require this particular data structure so that the program becomes systematic. Whatever the structure we are representing within our programming language, it should be systematic. Then only we will be able to perform, or we will be able to understand the program. If it is not in a systematic way, what will happen automatically? No one will be able to understand that particular program except the one who has written it. So that means the program becomes complicated. So to making sure that complication is getting reduced and everyone can understand the programs easily, we are using this particular concept called as data structures. So here they have provided some kind of structure using which we people can arrange the elements in a proper order, and we can use them sequentially. So that is what we have seen in this particular thing. And then we have seen several different type of classifications of data structures. Something like we discussed about something called linked list that we are going to discuss shortly in the second unit. Then we discussed about something called as tags. Then we have discussed about queues. Then followed with that, we discussed the most familiar one, something called as arrays. Then we discussed non-linear data. Remember? So these are linear data structures. And whereas coming to the non-linear data structures, what are those we do have? Something called as trees. And apart from that,
Graphs.
we have something called as graphs. So these two are what we comes under your non-linear data structures that we have discussed it, okay, in the previous session. And followed with that, we have seen some operations. What are the operations we can perform on these linear and non-linear data structure that we have seen? So today we will be trying to cover something related to this, that is something called as abstract data type. Followed with that, we'll be discussing about preliminaries of algorithm. Means what do you mean by algorithm? Anyhow, you people are familiar what do you mean by algorithm, because C programming has been completed for you people. So you will be much more familiar. But anyhow, we will be discussing some portion of it, and what are the other things, the properties that exist in that. And this is also related to algorithms only, something called as time and space complexity. So every program what we people usually write up, we will be having certain time and space complexity that we should determine. Okay, so whenever you're writing a program, how, suppose for example, if I give a simple program to write, so if there are 60 students in a particular group, so all the 60 students will be writing their own logic. Then if I wanted to find out which one is best among those 60 programs, I am having right now 60 programs, exactly 60 new programs I'm having it. So how can I determine which one is the best program among these 60? So I will be measuring the program with respect to time and space. So the program who is taking less time to execute and which is occupying less space will be the best one. That is what we call it as optimal one. Okay, so these three are the one what we are going to cover in this particular session. So coming ahead, first we will discuss about something called as abstract data type. So this is one of the most familiar topic which we have. Based on this only your entire data structures is based on abstract. What do you mean by abstract? Let me first define the meaning of what do you mean by abstract here. Abstract is nothing but in general we call it as just in the sense reducing the quantity is what we call it as abstract. For example, you have been given a 3 pages story. I have given you some nice story, some romantic story, or some horror story, some theoretical or action movie story. I have given a 3 pages story, okay? And I'm asking you people to convert these 3 pages into a single page and give me the entire information. Means whatever the content is present in these 3 pages, you should reduce, cut short it, and you have to make sure that you are representing everything in a single page. Okay, this is something like you people are watching a 3 hours movie. Let us suppose a latest movie has come up. You people went and have you seen the movie. Now I am asking you people, okay, take 10 minutes and tell me the entire story of that particular movie. Means within 10 minutes, you should be able to narrate that 3 hours movie. That is what we call it as abstract. Means what you people are going to do, you will not be showing the main content of it. You will just provide a gist of it. Gist is nothing but some abstract form of that particular representation. That is what we call it as abstract. Whatever the means like cut shorting it, okay, reducing it, meaning will not change. Remember, the meaning will be same. Whatever you are showing means with the 3 pages, whatever you have represented related to a story, the same story you are representing with a single page. There will not be no change in the meaning, no sequences, nothing. But you have reduced it from 3 pages to a single page. That is what we call it as an abstract. So here also what we are going to do is whenever we are writing complex programs, very complicated programs, whenever we are writing it up, we will be cut shorting it. Means how we can cut short is by using functions. uh, Yeah, so how we are going to do it is we will be reducing that particular thing. Whatever the program we are going to write it up, we will be simply reduce into a shorter form. Okay, how we are going to reduce, I will tell you. So data type, let's go for the next one. We have something called as data type. For timing, you remember this. I'll give an example so that you can understand this. Next, we have something called as data type here. What do you mean by data type? Here is nothing but whatever the primitive data types are provided within the program, that is what he's calling it as data type. That is nothing but if you talk about C programming, we have something called integer, character, right? String. Then we have something called as float. So all these things will be coming under into this particular data types. Okay, so that those are the one which are given by the program. Abstract means we will be using these data types and we will be declaring some data. We will be declaring some data. Along with the data, we will be declaring some operations which will be performed on that particular data. Okay, we will be declaring some data. For example, let us suppose I'm declaring int a comma b comma c. So what I did exactly here, I have declared 3 different variables. On these 3 variables, I'm going to perform some operations. What are the operations I am going to perform? Let us suppose add. Then I'm declaring something called as subtraction, and then something called as division. Okay, and in front of this, you people can write it as main and here like this. Okay, so I think it's not so clear. So this is something like I will give you an overview here, something like int main. This is a main method. I'm not writing the entire complete program because I'll show you later on. So here you people are declaring something like int a comma b comma c. And on these 3 variables, you're performing operations. What are the operations you're going to perform is add. Then we have something called as subtract. Then we have multiplication, etc. Okay, and then you're writing return 0. Since I have declared the main method as int, so I have to write this return 0. Now this is the program. You can see this. This is what I'm calling it as the main program. And this is what we call it as an abstract program. Why I'm calling it as an abstract program here? Because if you see here, it doesn't contain the implementation detail. If you see here, I have declared the 3 variables. What are the operations I'm going to perform here? That is nothing but addition. But you don't know what kind of logic I am going to use in order to execute that particular. Whether I will be using C equal to A plus B, or whether I will be using something like return A plus B. This is one logic. This is one logic, this is another logic. So you can either implement in this way or you can implement in this way. Or if you want, you can use another kind of way also, whatever you would like to use. But I did not mention it. I did not specify here in this particular scenario. That is what he's saying. So this is what we call it as abstract data type. So your abstract data type consists of data and operations. It consists of
సౌండ్ తగ్గిస్తుంది.
yeah. Yeah. So here in this particular scenario, what is saying ADT abstract data type consists of data. Followed with that, we do have something called as operations. Yeah. So we do have a data here and followed with that we do have operations. Okay, so only these things are there. If I ask you the implementation, these operations are specified. If you see here, these are the operations what are there. I am simply specifying what I'm going to do here. So user will be able to know, okay, I'm going to perform addition, subtraction, multiplication, but how I'm going to execute them, no one knows. What is the logic you have written in add? What is the logic you have written in subtraction? What is the logic you written in multiplication? No one knows. I will write them in a separate program. I will write a separate program like int add, and within this I will be writing the logic. This will be present in a separate file, x file. This is present in some y file. This is y.c, and this is some other x.h file, header file or something. And this header file I will be importing here in this scenario. Like you people are doing it now, hash include std io.h. You people are using it. What you're doing exactly here, you people are simply writing printf, and you're simply writing some logic here. Means you're writing enter hi, how are you, whatever. So what is this printf here? This is a method. If you see here, a method begins with a bracket, closes with a bracket. This is a method, printf, and you're writing a semicolon. So whenever you're representing the the methods in this particular way, specifying the methods, we specify with a semicolon, but that doesn't mean that is a statement. Remember that. So here printf is nothing but a function we are using from stdio.h, and this stdio.h will consist of a program like this for print, something like int. Since it is string now, so it is string printf. So here will be a function, and here there will be a logic which will be printing your information, whatever you're typing in this particular scenario. The same thing is what exactly he's showing in this particular thing. So that is what exactly it consists of. So remember, every abstract data type consists of only two things. First is declaration of data. So you people are declaring data, right? Int a comma b comma c, you people are declare, this is what we call it as a data. And declaration of operation, what are the operations I'm going to perform? Let us suppose add here, then I'm going for factorial. Okay, factorial, something like this. So these are the two operations I'm performing on this. So this combination is what I call it as abstract data type. So it doesn't have any kind of implementation details. Remember, implementation in the sense logic. So there are no logic represented how I am going to execute this function. Simply I have represented like this. So that is what is saying, declaration of data and declaration of operation. Now along with that, we also have something like, so second statement is also same. It is a collection of data together with set of operations. So add, subtraction, multiplication, as I shown you, that is what comes under that. So this is a formula type based I have represented here. ADT is equal to nothing but data plus what are the operations you are going to perform on that particular data. So here the specifications and implementations are the two things you people have to keep in mind. Whenever you're specifying something like add, you people are specifying like subtract. You, what are you doing? You people are simply specifying. But how this is implemented, that you are not specifying it. That is what he is saying here. Either you are specifying specifications and then you are going for implementation. Now this implementation details will be present in a separate file. And in the separate file, you will be having this specification details. So this will consist of data and operations. So that is what comes under specification. Now, how these functions are going to get executed, that information is present in this particular implementation. So you can apply this abstract data type using linked list or arrays, depending upon your choice, whatever it is. And the commonly used data types, what we do have here is something we call it as linked list. We have linked list here, stacks, queues, binary trees, graphs, and etc. So all this, whatever we had discussed in the previous session, we can use this in order to represent this ADT. And we are going to use also, don't worry. In the coming sessions, I will be showing you different programs where we will be using all these concepts in order to execute it. Okay. So that is what he's saying. So you are given a small example also, something like stack and queue. If you talk about a stack, what did I say? Every stack will consist of, if you remember in the previous session we discussed, every stack will consist of a variable called top. That is nothing but you can call it as an index also. And using this top only, you can either add an element or you can delete an element. So how to add and how to delete for stack? In stack, you are having an operations. It is having something called as push. Then it is having something called as pop, and then it has another function called push. So these are the three functions that are going to be used in this particular stack. Push in the sense adding a new element into this particular stack. Pop in the sense removing one element from this particular stack. Peep in the sense which element is present in which location. That information is given by this particular function. So how this push, pop, and peep are actually implemented, no one knows. That we will be writing in a separate file. But the main method will consist of only these functions, these methods. push, pop, and peep. That's it. That is what comes under your abstract data type. Let's see a practical example here. First, you people don't consider the right hand side, whatever I'm representing here. Just focus on the left hand side, the main method, what I'm showing you here. So this is a program here. So I have taken a program of a factorial. I think you people are familiar with factorial. For example, if 5 factorial, if I take up here, so what is the value you get? 5 star, 4, 3, so 2 into 1. So this is something 5 first 20 into 360 to 120 into 1. So it is 120. So I have taken the value. So here factorial 5 factorial I'm doing it here, so the result what I'm going to get is 120 here. Fine, you people might be familiar since you people have completed C programming. Let's focus on this particular concept called abstract data type. If you see this particular box, this one main method, you can see here I have represented a variable int ans, that is nothing but answer, and this variable is of type integer. Now answer equal to factorial of 5. Did you see this? I have used a function here. I have used a function, or you people usually call it as a method. So I have used a method. Which method I have used? A factorial method. And within that, I have sent a single parameter called as 5. I have sent a single parameter here. And simply after that, I am printing the statement. The factorial value is %d ans. So whatever the value I'm going to get, that I'm going to print it. Since I have written the method, main method as integer, so definitely I have to return 0. So this is what. Now, forget about the right side I told you. Now, based on this particular program, can anyone can guess what is the logic we might have written in this factorial method? Can anyone guess it up? It's not possible, right? If you see here, this particular concept in this particular thing, okay, forget about this particular. So this one you don't see, this one also you do not see. This is the program which I gave you. Now with the help of this, will you be able to understand? What you understand is, you can understand that, okay, I have used a variable here, and using that variable I am doing some factorial operation, and whatever the value is coming, I'm storing in this answer, and then finally I'm printing it. So most of the programmers will have a doubt, okay, what kind of logic sir might have used in factorial method? What kind of logic sir might have used in factorial method in order to do it, or whether he has used a common kind, other different type of logic, means without regression he has written the logic, what exactly he did it. So that is what I'm representing onto your right hand side. You can see there are two methods. The first implementation is with regression, the second implementation is without regression. You can see here very clearly. Okay, the first one what I have seen here, int factorial, since I written here factorial n factorial, and I have sent the parameter 5. So I'm declaring now. So this will be in a separate file. This is a separate file. Usually in C programming, we write it as a separate method, not within the main method. So after this brace, we will be writing this particular thing. So int factorial int n, if n is equal to 0. So this is a logic for representing. If the value, whatever we want to do the factorial, we are giving the value 0. Definitely the output you are going to. So 0 factorial is nothing, which is equal to 1. In case if it is not equal to 0, so there exists some value 2. So 2 into 1 we have to do it. So that is nothing but return n star factorial of n minus 1. So something, what is the value we gave for this particular factorial here? 5. So that value will be passed here. 5. So 5 is equal to 0 here. 5 is equal to 0. No, the condition fails. So definitely this will not be executed. It will skip and it will come to this particular location. And here what we are writing, 5, return 5 star factorial of n minus 1. So what is the value of n here? 5. 5 minus 1 is 4. From here again it will go here. Now this time the value of n is how much? The value of n right now 4. So again it will check the condition whether 4 is equal to 0 or not. It is not equal to 0. So definitely again it will skip and it will come here. So return n star. So already there is 5 here. Again you will be getting 4. So what you're getting? 20 star factorial of n minus 1. What is the value of n here? N. 4. 4 minus 1 is 3. And this process continues. So next time what you're going to get here? So 5 into 4 you're going to get. So what you got here is 20. Then 20 into 3 you're going to get 60. Then 60 into factorial of n minus 2. 3 minus 1 is 2. So 60 into 2 is 120. Then 2 minus 1 is 1. So 120 into 1 is 120. So this is the output you're going. So this will be returned from here. From here, that value will be coming here. What is the value we got here? 120. And that 120 I'm storing in this particular variable. And finally, I'm declaring %d since it is of type integer, and I'm simply using that particular ANS. So this is the way how exactly your program is executed. Now let us suppose this is written by one of the student. Let us suppose roll number one. Okay, roll number one has written this logic. So there might be some other person, let us suppose roll number 20. She has written, she is very good in programming, and she what she did is she written in a different logic. She has implemented second one. She did not use regression in order to implement it. She has used a second logic what is being represented here in this particular case. So here what we are doing, first one is same in factorial, but in this we are declaring a variable int I, result is equal to 1. And I'm starting from 2, I equal to 2, I less than equal to, here the n value is 5. So I plus plus. So result star equal to I. What is the value of result initially? 1. So 1 into, what is the value of I? So 2. So 1 into 2. Then what you are going to get result here? So result is equal to 2. Then after that, what we are going to, again we'll come back to here. Then the I value will be incremented. Now since I value is initially 2, now it becomes 3. So since it is becoming 3, what we had to do, return star equal to I. Return star equal to is nothing but this is result equal to result star I. That is a short form we are written using star equal to. Okay, this is a short form for result equal to result star I. So here what I'm going to do, what is the value of result I just got here is 2. And after that I have incremented the value of I. Now I value is how much here? 3, isn't it? So I value is 3. So 3 into result 2. 3 into 2 is how much? 6. And after that 6 into 4, 24. So 24 into then 5 means this time this row number 20 has represented the logic in a different manner. Here how we are doing it in this logic, 5 into 4 into 3, 2, 1. But here row number 20 has implemented something like as 1 into 2, 3, 4 into 5. Did you see? Both the logics are different, but you will get the same output. That is 120. So this is the way how we people can separate. This is what we call abstract data type. If you look at this main method, this is what we call abstract data type. It consists of data. So this is the data. You people have declared it. And this is the function. And that function only we are calling it as operation. That is a function we are calling it as operation. So we don't know. So here only we have specified the operation, what we are going to do, but no one knows how that operation is going to be implemented. Means what is the code present in that particular function? No one knows. So some people might be writing like this. Some people can write like this. That's up to their wish. So this is the way how it is exactly performing the operation. This is what we call it as an abstract data type. You can see here, the main method needs to know only the factorial purpose. Means here you will be coming to know what exactly this factorial is going to do. That is 5 into 4, 3, 2, 1. And output should be 120. This is what you know. But it will have no information of the internal coding of the factorial. How we have written the code in order to perform this 5, 4, 3, 2, 1. Like you can see in this we are doing 5, 4, 3, 2, 1. We are multiplying them and we are doing it. But in this scenario, this is 1 into 2 into 3 into 4 into 5. Output is same 120. Here also the output is 120. But no one knows that how the internal coding has been represented. And this is what we call it as an abstract data type. Let me show you the practical ones also. This is a code I have written here. So first, so I have kept this one. You can see here, I kept this one in braces because you cannot execute both at a time. Okay, two different factorials are there, so system will get confused. So in the first I'll execute this one. In this, what happens exactly? How we are doing it is 5 into 4 into 3 into 2 into 1. So output you should get 120. So directly you will get the output in this particular case. So how to execute it? You people I think know. Execute, compile and run. So it has compiled it. Yeah, you people can see here, I guess. Okay, let me use magnifier. Yeah, it's not getting opened up. Anyhow, so this is the value. So you can see here the factorial value is 120. I'll little bit zoom it up. You can see here the factorial value here is given as 120. Okay. I think you people are able to see the screen here. The factorial value what you people have received here is something called as 120. So let me erase this. Now this time I will be executing the second one. So here I will be keeping it in comments here, this one. Dash. So here I'm just trying to remove them, this one, and then I'm removing this one. So this time I will be executing the second implementation technique. What we do have here, you can see here int I result equal to 1 for int I equal to 2, I less than equal to n I plus plus. This is now how this is going to execute the program here. This will be like 1 into 2 into 3 into 4 into 5. So the output you people are going to get is 120. So let's see. So go to the execution part, then you will be compiling and running that program. Oh, immediately got it. You can see the factorial of a given value is 120. So how much time it has taken? The process has exited after 0.09 seconds. So it took around 0.09 seconds to complete this particular task. Means the time complexity for my particular system is 0.096. The program's time complexity is 0.096. That is what comes under your time complexity. So I hope you people have a good idea about this particular thing. Okay. Yeah. So this is what exactly he defines here. I hope you people have got a clear idea about your abstract data type. Abstract is nothing but simply specifying the data and the functions. But how that functions are implemented, that details will not be present in this particular method. That is what we call it as abstract data type. And what is the best part? What is the main purpose of using this? Here you can see here. This is a normal just example which I am showing you people here in this particular thing. You can see here that we have a int. Okay, whenever the program this particular program starts executing it, this factorial will be requesting. So request of operation factorial of 5. You can see there is a wall here. This is what I mean to say. This is a wall. This wall, what it is going to do is this wall will help in protecting this implementation from this particular program. Means only it with this program will not know how this particular factorial has been done. It will only get the output. It will be giving the parameter 5 and it will be getting the value something called as 120. But how this is implemented, that will not be provided. Why? There is a wall here. There is a protection is provided here in this particular scenario. So whenever you execute this particular program, so factorial of 5, what it will do is it will simply send that parameter to this function. So here 5. And here you people have written the logic which will be performing operation on this variable 5, and then it will simply give the result. So 5 factorial, the result is 120. That 120 will be given to it. So this system, this particular program will never come to know so how the logic has been implemented. And do you know what is the best part of writing like this is you can use this particular function multiple times. You people can use this particular function multiple times. This particular factorial you can use in any program. Suppose you have written you're writing or developing a new application where you want to use factorial. If this particular factorial function or the program you have written in a separate file, you can simply dump that file in your particular program using a header file, and you can start writing the logics and all. That is what comes under in this particular scenario. And moreover, whenever you people are using ADT, it actually provide interface. This is the diagram which I wanted to show you. Now this is your program. Like you people usually write programs in C, na? This is your main program. Whatever the main method you people are writing, and within this, whatever the logic is writing is what the program is there. Now, in between here, in between this particular main, you are performing some operations, add, subtraction, factorial. So all those will be represented like this as an interface. This is an interface, you can say. This is a wall of a abstract data type operation. Now this wall will consist of the method. So whenever you people are calling, whenever this main program is calling add, so this method will be initiated. So whatever the data structure you are using within this main, I mean add method, something like, you have written add here, and you have written c equal to a plus b, and then you can write simply return C, and that value will be displayed here in this particular scenario. This is what comes under here in this particular case. Same way, if you wanted to find any number, so these are some of the methods provided, like add, remove, subtraction, deletion, multiplication, factorial, like that. These are the some of the things. This is normal representation to show you that this is an interface through which every program will be going for a particular operation to execute. So in place of remove, you may be having factorial, like this one, fact. Now you can see this particular fact, this is present. So whenever you're giving factorial 5, so this here you're giving factorial 5, that 5 will be given to this. From here it will go here, it will use any one of the method what we have seen in there previously. So it will be, yeah, this one. So it will be using either the first implementation, or it might be using the second implementation. Either it may be using this, or it may be using this, depending upon which program you have written or which logic you people have implemented, and it will simply execute that particular logic. Okay, so I hope it's very clear. So you people might have understood what exactly that means. So what is the advantages of this particular abstract data type is code becomes easier. You can see in the previous part here, if you can see here factorial, if you are written in a single logic all the information, the number of steps will be more. But if you can see here, simple factorial program I have written using 4 statements. Remember, this is a separate file, this one is a separate file, and this one is separate. These two files, this 1 and 2, these are written separately in a separate .c files. These are not present with this. This is your main program, this is what you people are going to execute. So how many lines you have written here? 1, 2, 3, 4. So there are total 4 lines. So code becomes very, very easy. You have written in short. Okay, but if you written it the factory also you might have done here, means it will be coming as 10 lines of code or 20 lines of code, depending upon the logic whatever you people are writing. But now what I did, since I am using abstract data type representation here, I have only 4 lines of code, that's it. I'll simply execute this one. So suppose this is something factorial dot c, so I will execute only this factorial dot c. Automatically I'll get the output as 120, that's it, using these 4 lines. But the remaining lines are present from here, it will go to the other file where exactly this factorial file we have written, method we have written. From that it is going to execute this, and it is going to give you the output. So that is the best part, or that is the main advantage of your abstract data type. Second one, what is saying, implementation of implementation of ADTs can be changed without requiring changes to the program. So whatever the implementations we are doing for abstract data type, you can do it up without requiring to change the program. So here, in this case, what it means to say that if any user is not satisfied, suppose roll number 20 is not satisfied with this particular logic. So she will simply change this logic, and she will write the same logic what we have implemented in one. Okay, so she will be showing the same logic what she has implemented, means someone else has implemented in one. She can change it. So do we have to change this main program? That main program we don't have to change it. That is what he's saying in this particular scenario. So we don't have to change this particular logic. This will be remaining as it is. But this logics you people can change. This first way of representation. Maybe the person who has written this one, he wants to change the logic like this, and the one who has written in this way, they wanted to change a logic like this, they can do it, no problem in that. So implementation 1 and 2 can be interchanged, or they can exchange it, or they can write it whatever the code they want. But if you talk about the main program, whatever I'm representing here, this will not be changing here. This will not be changing, this will be as it is. This will not, this particular main method will never change. That is what he means to say in this second statement. Okay, and the last but not the least, ADT can be used in future programs. Obviously, As I told you, the same ADT logic, whatever we have represented here. Okay, this implementation 1 and 2. So if we have another program where factorial concept is required, we can use it. We can use this factorial program and we can implement it. That is what he's saying in this particular scenario. So that is all about for your abstract data type. I hope you people have understood how exactly it works, how the logics are written and how they are separately written here. Okay. And next we have something called as algorithm. I think you people have a familiarity with this particular concept called algorithm since you people have completed C programming. So still we will discuss some portion of it here. So what do you mean by algorithm here is nothing but it is a step-by-step process. It is a step-by-step procedure you can say, or you can say a process. Okay, so in which we will be executing the instructions one after another to make sure that we get a perfect output. Whatever the output we are expecting, to get that output, we will be performing the operations step by step, one after another. That is what comes under here as algorithm. Okay, so it is a step-by-step process which is used in order to define the set of instructions. So whatever the program you people have written, the statements, whatever you written within the program is nothing but that is a process. Okay, that is what he's talking about here, instructions. So that is a procedure. So one by one, you will be executing those instructions so that whatever the output you people are expecting, you're getting that particular output. That is what he means to say in this particular scenario. And generally they are independent of underlying languages. Obviously, if you are using a Python language, we have a Python language. If you're using a Python language, there the algorithm will be same, but the logic might be different. The way of representation or the syntax will be different. If you're using C programming, so you will be having a different syntax. You might be using a different kind of syntax here. Just a minute here. And if you go further here in this particular case, if you talk about C++, the C++, the syntax of representing the structure will be different, but the logic will be same. So that is what he's saying. Algorithm will be common for one particular statement or the problem, whatever you're executing it, but the way of representation, okay, the syntax will be different depending upon the language. So that is what he's saying. It is independent of underlying languages. Means once you're writing an algorithm, the same algorithm you can use it for C programming, C++, or you people can use it for Python programming, whatever it might be. Okay. So I hope you people have understood what I mean by algorithm. Now this algorithm they generally have some characteristics here. 5, 6 characteristics we are having, and you people have to remember every time. First thing is unambiguous. Okay, unambiguous is nothing but not misleading. The other name for unambiguous is misleading. Means whenever you're reading some statement, it clearly understand by a particular student. A particular student can clearly understand that particular concept. That is what comes under here unambiguous. So whatever the steps you people are writing in your program, they should be very clear, so that if your friend is actually seeing that particular program, she should be able to understand that particular program easily. It's not that it should not be like a confusion to that particular your friend. Okay, that is what we call it as unambiguous. Then we have input. Input in the sense an algorithm should have zero or well-defined input. Okay, so it should have at least one output input. So whenever you're writing a program, at least one input should be there for that particular program, because you know that you're writing a program and that program doesn't contain any input, then it is of no use of writing that particular program, right? That it becomes a static program, and static programs may not be useful. So if it is dynamic, then it will be useful. That comes under here input. Then we have something called as output here. So if you talk about output here in this particular scenario, what he's saying is that every algorithm should have one or more well-defined output. Obviously, for example, let us take an example of addition of two numbers. You have written a logic C equal to A plus B. Now, every time I'm giving a different input, I will be getting a different output, right? So let us suppose I gave 5 plus 5 in the beginning. So what is the output I'm going to get? 10. If I give the output as something like 6 plus 5, what is the output I'm going to get? 11. So that is what he's saying. An algorithm should have at least one or more than one well-defined output. The output should be perfect. Then we have something called as finiteness. That means it should terminate after a finite number of steps. It shouldn't be like looping structure. Here the meaning of this particular statement 4 is that whatever the program you are writing, it should complete with certain number of steps. It is not that it should keep on writing the program. No, not like that. It should have some end. Okay, it should have some dead end, something like if you're writing a program. Okay, let me show you. So here let me take a new file. Okay, I'm just going to create a new file here. So here in this case, I'm writing addition of two numbers program. See here. So first thing what we are going to include, header file hash include stdio.h. Then I'm giving main method. So int main. Then I will be declaring three variables. Now what we have to do, we have to print the statement to get the values of a and b. Then I have to write something called as scanf. So I'm simply copying this. Okay, copy pasting it. So here I'll write enter the value of b here. And then here I will be writing address of b. Now what I'm doing, I'm simply writing c equal to a plus b. And now I'm going to print the statement. What is the statement I need to print? So sum equal to percentage. Since the variables have taken an integer type, so I have to write %d and then finally c. Done. So you can see here the main method I have written as int. So I should write something called as return 0. Okay. Now I have to save this program. So Control S. Shortcut is Control S here. So here I'm going to save it up. So this is a normal sum program. So I'm writing it as sum. And since it is a C program, I should remember that we need to replace this particular type also. I should replace this as C and save. So you can see here the name has been changed here sum. You can see here sum.c. Now I simply have to execute it. So compile and run here. I execute it. So first thing what I'm getting here is enter the value of A 5. Then enter the value of B 5. Sum is equal to how much you got here is 10. So I think you people can understand, you people are able to see it. So enter the value of A, how much what you are giving 5 and 5. You're getting a separate sum equal to 10. Again, if I execute the same program, this time I am giving the value something called 5 and 8. So what is the sum I got here? 13. So you can see every time you're giving a different input, you people should get a different output. And here if you look at it, this particular program is getting executed, means completing within certain number of steps. How many steps I have used here? 12 steps. So within 12 steps, you people are able to complete this particular program. And that is what he's talking about in this particular fourth point. Every algorithm should terminate after a finite number of steps, means certain number of steps should take and then it should terminate. It's not that it should keep on executing or writing the same lines of code again and again, again and again. Now then what will happen is it will never stop and it will become a huge problem. The fifth point what we have is with respect to this is feasibility. Feasibility in the sense nothing but he means to say in this particular scenario is that it should be very feasible for accessing the resources. You should not try to give a resource which we cannot access. So that's the reason programming language itself give you the data types. That is int. Int can be accessed easily. Char also we can access double, long double, Okay, all these we can access very easily. This is very easily can be accessible, but that is what is saying. So whatever the resources are required in order to execute that particular program, they should be very much clear. Then we have something called as independent here. Independent means the algorithm should be step by step, means it should be executed in a step by step way, and every step should be independent of other. Yeah, sorry. So here what is saying in independent is algorithm should have step-by-step direction, which should be independent of any programming code. So whichever programming language you are writing, that doesn't bother. The algorithm should be step-by-step manner. It should be understandable, and it should be independent of the programming language. Suppose you are implementing whatever the program I have shown you right now, addition of two numbers and all. You people have seen it that I have written in C program. But if I the same program I write in C++, then also the algorithm will be same for this particular scenario. It will not change. That is what he means to say in this particular thing. Okay, so this is the examples he has given here. You people can just watch out. So if you see in this particular thing, I'm having here something called addition of two numbers here in this particular thing. So these are the way how you people can write algorithms in this particular. So step by step manner. So addition of two numbers, I have just shown you the program here. How to write the algorithm for that particular program? Simple. So first thing is input first number as A. Then you will be inputting the second number as B. Then set sum equal to A plus B, and then finally sum. And finally the last step is end. Well, some cases you people will be starting with start. Well, algorithm you can start. The step one will be start. Then input first number is A. So that depends. However you want to write, you can write the logic. Algorithm is similar to this. Okay. So you can write like this, or you can initially start with the start. So step one will be start. Then step two will be input the first number. Then step three will be input second number as B. Step four will be set number equal to A plus B. Then step five will be print sum, and step six will be end. So that depends. You people can write like this, or you people can start with the start and end. That's up to you. So here you can see addition of two numbers. We have done the example. Same way equality. In the next example, we have seen the equality of two numbers. Equality means if we I'm taking two variables A. So if the first variable I'm giving the value as 5, the second variable I'm giving the value as 5, it should print that both are equal. But if they are not equal, it should print that both are not equal. So first number, input first number as A, then we are given the input the second number. Now we are checking the condition. So we are using if statement here and checking it. So if A is equal, sorry, if A is equal to B, he is asking you to print that it is equal. If it is not equal, then else print not equal. Finally, end of if, and then finally step 4 end. And even if the other program, what we have is like printing 10 natural numbers, you can do it here. So when you wanted to print some 10 natural numbers, what is the logic here? I want to print 1 to 10. So simply for loop I have to take for I equal to 1, I less than equal to 10, I plus plus. And simply I will be printing the statement. That is what I'm doing it here. See, initially the value of I I'm setting it to 1. So I is equal to 1. What is the n value I'm going to take? 10, since I want to print 10 numbers. So I will be repeating step 3 and 4. Well, so here he is used while statement and he has executed. In the next session, I will execute them and I'll show you practically how this particular logics work. For the meantime, what you people have to do in the coming session, you try to write an algorithms for these three problems. The first one is swapping two values. You know how to do a swapping with the third variable. So A equal to B, B equal to C, C equal to A. So this is the logic which you have to use. I want you people to write an algorithm for swapping two values. Same way, try to write an algorithm for finding the largest of two values. Take two values, A and B, and which one is greater, that you execute it. Okay. And the third one is determine whether given number is even and odd. I think you people have already completed writing programs for all this in C language. So now you people have to write simply algorithms for this in this similar fashion. Okay, so you people just try it up. In the next session, I will ask regarding this particular thing. So we will stop here in this particular session. In the next session we'll be discussing about the different approaches, how to design it, and what are the things we have, and then the control structures that are used in algorithm. Followed with that, we have time and space complexity and classification of time complexity. Okay, so this all we'll be discussing in the next session, and this is all for today's session. Thank you for watching.